When giants vanished, the unsolved mystery of the dinosaurs' end. For over 140 million years, dinosaurs dominated the Earth. From the towering, plant-munching sauropods to the fearsome, razor-toothed theropods like Tyrannosaurus rex, they filled nearly every ecological niche on land. They adapted to changing climates, continents that drifted and fractured, and an ever-shifting web of life. Then, about 66 million years ago, they disappeared. In what amounts to a geological blink, these creatures that had ruled the planet were gone. The cause of their extinction remains one of science's greatest unsolved mysteries. The story of the dinosaurs begins in the Triassic period, around 230 million years ago. Small, nimble bipeds emerged, competing with other reptiles in a post-Permian extinction world. Through the Jurassic and into the Cretaceous, dinosaurs diversified spectacularly. They evolved into a dizzying array of forms: horned Triceratops, crested Parasaurolophus, the armored Ankylosaurus, and swift, bird-like Velociraptor. Dinosaurs weren't alone. Mammals were around too, but tiny and nocturnal. Pterosaurs ruled the skies. Marine reptiles like plesiosaurs and mosasaurs ruled the seas. But on land, dinosaurs reigned supreme. They grew larger, faster, smarter. Some developed feathers. Some may have hunted in coordinated packs. They weren't just cold-blooded brutes. They were thriving, adapting, and sophisticated. They also spread across the globe, leaving their footprints, literally and figuratively, in nearly every corner of Earth. From arid deserts to polar forests, dinosaur fossils have been unearthed on every continent. This global reach only amplifies the mystery of their disappearance. How could a dynasty so vast, so well adapted, fall so completely? So what happened? The most widely accepted explanation is the Chicxulub impact. Around 66 million years ago, a 10 to 15 kilometer wide asteroid struck the Yucatan Peninsula. The impact released energy a billion times greater than the Hiroshima bomb. It triggered tsunamis, global wildfires, and sent soot and sulfur aerosols into the atmosphere, blocking sunlight and collapsing ecosystems. The impact theory is compelling. The geological record reveals a thin layer of iridium-rich clay around the world at the Cretaceous-Paleogene (KPG) boundary, an element rare on Earth but common in asteroids. Beneath the Gulf of Mexico, a massive crater matches the expected age. Yet, the asteroid theory, while popular, is not a closed case. At the same time as the Chicxulub impact, massive volcanic eruptions were occurring in what is now India. The Deccan Traps, huge layered basalt flows, erupted over thousands of years, releasing vast amounts of carbon dioxide and sulfur dioxide. These gases may have drastically altered the climate, acidified oceans, and weakened ecosystems. Could the Deccan volcanism have primed the Earth's biosphere for collapse, with the asteroid delivering the final blow? Or did volcanism alone do the job? Some scientists argue that the timing, duration, and intensity of these eruptions may account for much of the observed extinction pattern, without the need for a space rock. It's even been proposed that the asteroid impact may have triggered intensified volcanic activity, creating a lethal 1-2 punch. New geochemical evidence suggests the eruptions may have spiked right after the impact, potentially combining effects in catastrophic synergy. Paleontologists have long debated whether the extinction was sudden or gradual. Some fossil records show a decline in dinosaur diversity before the impact, suggesting they were already in trouble. Others argue the data is skewed by the patchy nature of fossil preservation. Fossils aren't evenly distributed through time, and gaps can easily be mistaken for evidence of decline. Did some groups decline slowly, while others thrived until the very end? New findings continue to reshape our understanding. In 2020, fossilized dinosaur tracks in Colorado hinted that ecosystems were still robust just before the boundary event. Meanwhile, other data from North America suggests a drop in herbivore diversity late in the Cretaceous. Other parts of the world tell different stories. In South America and Asia, for instance, some evidence points to stability right up until the impact. These contrasting patterns complicate any single narrative and highlight the importance of a global perspective. Not all dinosaurs vanished. Birds, the living descendants of certain theropods, made it through. Why? Theories abound: small size, varied diet, high reproductive rates, ability to fly. These advantages may have given them the edge in a post-impact world. Recent research has suggested that birds' beaks, more efficient at processing a range of food than the toothed mouths of other theropods, may have been a critical survival trait. Others point to their nesting behaviors and possibly faster generational turnover as key advantages. Mammals, too, began their rise. With niches left vacant, they diversified rapidly, setting the stage for the age of mammals, and eventually humans. Though long overshadowed by the dinosaurs, mammals had coexisted for over 100 million years. After the extinction, they radiated into the open ecological spaces with astonishing speed. The extinction of the dinosaurs sits at the intersection of geology, biology, chemistry, and astronomy. The data is ancient, incomplete, and difficult to interpret. Every few years, new fossils or better dating techniques shift the debate. Tools like CT scanning, isotope analysis, and even satellite imagery continue to revolutionize our ability to reconstruct the past. Perhaps it was a perfect storm. Ecosystems stressed by climate shifts, battered by volcanic gases, then obliterated by an asteroid. Or perhaps we've yet to discover a key clue, buried in the sediment of deep time. Could a third factor, such as a disease or subtle shifts in plant life, have played a hidden role? As we continue to unravel the story of their extinction, a wide array of theories has emerged, offering speculative and imaginative perspectives on how these creatures met their end. Some more unconventional ideas suggest that the dinosaurs were victims of cosmic disturbances that they couldn't have anticipated. Cosmic radiation, for example, might have bombarded the Earth from a distant supernova or a stellar event, altering the planet's atmosphere and genetic makeup. Such radiation could have crippled the dinosaurs over time, making it harder for them to adapt to the rapidly changing world. Another theory suggests the dinosaurs suffered from what could be described as evolutionary fatigue. After ruling the Earth for so long, they may have reached an evolutionary limit, becoming too specialized or rigid in their adaptations. This stagnation could have left them vulnerable to the environmental shifts brought on by the asteroid impact and volcanic activity. In a way, they may have simply been too successful, reaching an apex that ultimately limited their capacity to evolve further. Perhaps the dinosaurs were also afflicted by a gradual decline in their cognitive abilities. Their relatively small brains, especially in larger species, may have hindered their capacity to adapt to the ecological pressures of the late Cretaceous. As mammals, with their more complex brains and social structures, began to diversify, the dinosaurs' inability to evolve in terms of intelligence may have been a fatal flaw. These mammals, smaller and more adaptable, were in a better position to thrive in a world where survival demanded more than sheer size or brute force. Disease could have been another factor in the dinosaurs' decline. New pathogens, perhaps spread by evolving parasites, could have decimated dinosaur populations before the catastrophic events of the asteroid and volcanic eruptions. The fossil record shows that some dinosaurs suffered from injuries and diseases, suggesting that they were already weakened in the years leading up to their extinction. Starvation, too, cannot be ruled out. As climate shifts, volcanic activity, and other environmental pressures disrupted plant life, herbivorous dinosaurs may have found it increasingly difficult to find food. With food sources dwindling, the herbivores would have suffered first, leading to a cascading effect that left the carnivores without prey. One theory even posits the idea of egg-eating mammals infiltrating dinosaur nests and undermining their reproduction. Small mammals, particularly those that could scavenge or consume dinosaur eggs, might have quietly contributed to the dinosaurs' decline, making it harder for them to maintain their populations. In the realm of even more speculative ideas, some have even suggested that alien interference could have played a role in the dinosaurs' downfall. While certainly far-fetched, this notion has captured the imagination of some who wonder if extraterrestrial visitors could have played a direct role in the extinction event, perhaps through advanced weaponry or environmental manipulation. Ultimately, though, these theories are largely speculative, yet they emphasize the complexity and depth of the mystery. The story of the dinosaurs is not just one of natural catastrophes, but also of hidden factors: disease, cosmic radiation, cognitive decline, and ecological changes that we are still trying to understand. The extinction of the dinosaurs remains an ongoing puzzle, one with no easy solution. Every new discovery, every new piece of evidence, shifts the conversation and adds to the complexity of our understanding. But what is clear is that their disappearance was not the result of one singular event, but likely the outcome of multiple forces working in tandem. Even as we uncover more, the end of the dinosaurs continues to fascinate. They were the masters of Earth for more than 100 million years, a span nearly incomprehensible to us. Their disappearance reminds us that even the mightiest are vulnerable to the forces of nature, and that extinction can come suddenly, without warning. And so we keep digging, studying, questioning, because the story of the dinosaurs isn't just about their end, it's also about how life changes, adapts, and survives. Even in extinction, they have something to teach us. Their bones are gone, their kingdoms turned to stone, but their story continues, evolving with every discovery.